Let us revisit the topics semantic net and frames. We have seen that semantic net is a representation of objects in the form of a graph. And let us do some practical example on this topic. It has been prepared by Georgia Tech on knowledge base and artificial intelligence. The short video shows the representation of the knowledge of a figure using semantic network. We are having a figure and it is being converted into its corresponding semantic network. So let us see.
To understand semantic networks as a knowledge representation, let us take an example. This is an example that we saw in a previous lesson. This is A is to B as C is to D, and we have to pick one of the 6 choices at the bottom that will go in D. How will we represent our knowledge of A, B, C, and the 6 choices at the bottom? Let us begin with A and B. We will try to build semantic networks that can represent our knowledge of A and B. Inside A is a circle. I'll label it X. Also inside X is a diamond. I'll label it Y. Here is a black dot. I'll label it Z. We can similarly label the objects in B. So inside A are 3 objects, X, Y, and Z. So the first thing we need to do in order to build a semantic network for representing our knowledge of A is to represent the objects. So I have the object X, the object Y, the object Z, standing for the circle, the diamond, and the black dot. Now that we have represented the objects in A, we want to represent the relationships between these objects. So I have the objects X, Y, Z, and we'll try to represent the relationship between them by having links between the nodes representing the objects. These links can be labeled. So I may say that Y is inside X because that is a relationship in the image A. Similarly, I may say that Z is above Y because Z is above Y in the image A. I may also say that Z is above X because Z is above X in image A. In this way, a semantic network representation of the image A captures both the objects and the relationships between the objects. We can do exactly the same thing for the image B, the objects and the relationships between them. Y is above X. Now that we have represented our knowledge of image A and our knowledge of image B, we want to capture somehow the knowledge of the transformation from A to B, because recall, A is to B as C is to D. So we want to capture the relationship between A and B, the transformation from A to B. To do that, to capture the transformation from A to B, we'll start building links between the objects in A and the objects in B. Now, for X and Y, that is straightforward. For Z, well, there is no Z in B. So we'll have a dummy node here in B, and we will see how we can label the link here so that we can capture the idea that Z doesn't occur in B. So we might say that X is unchanged because X, the circle here, is the same as the circle here. Y, on the other hand, has expanded. It was a small diamond here, and it's a much bigger diamond there. Z, the black dot, has disappeared altogether, so we will say it's deleted. It's not there in B at all. I hope you can see from this example how we constructed a semantic network for the relationship between the images A and B. There were 3 parts to it. The first part dealt with the objects in A and the objects in B. The second part dealt with the relationships between the objects in A and the relationship between the objects in B. The third part dealt with the relationship between the objects in A and the relationship between the objects in B. In principle, we can construct semantic networks for much more complicated images, not just A and B. Here is another example of a semantic network for another set of images. Once again, we have the objects and the relationships, and then the relationship between the objects in the first image and that in the second image. Okay, let's do this exercise together. David, what did you come up with the labels for the various links?
So I looked at the vocabulary we used over here and decided to use the same vocabulary over here. Just like Z was above both X and Y, T is above both S and R. So I said T is above S and T is above R. Just like Y was inside X, S is inside R. so I said that S is inside R. Over here, I saw that S is above R, just like Y was above X, so I said S is above R.
Now, David made an important point here. He said that the vocabulary he's using here of inside and above is the same as the vocabulary that I had used of inside and above here. And that's a good point because we want to have a consistent vocabulary throughout the representation for the class of problems. So here we have decided that for representing problems of this kind in semantic networks, we will use the vocabulary of inside and above, and we'll try to use it consistently.
We have also seen that frames are closely related with semantic network. In other words, frame is an extension to semantic network. Whatever we represent in semantic network can be converted into frames. So they are closely related, and we can generate a frame from a semantic network. So we are approaching Georgia Tech on this topic as well.
We can also use frames to address the Raven's matrices problems that we have been talking about all throughout this course. In fact, as we do so, we'll note another interesting fact. Frames and semantic networks are closely related. So let's do this problem. Here was a particular image, and here was the semantic network for this particular image that we had come across earlier. I could rewrite this semantic network in the language of frames by first of all building a frame for each of the specific objects. So I have a frame for X, a frame for Y, and a frame for Z. So here are the frames for the three objects, X, Y, and Z. Let's look at the frame for Z in more detail for just a second. So here are the slots. The name is Z. The shape is a circle. The size is small, and it is filled. You can see it here. We can also capture the relationship between these two objects. So let's consider a relationship example. Here Y is inside X. Y is inside X. We can capture that through the slot for the object Y. Here is the slot inside for the object Y, and it is pointing to X, indicating that Y is inside X. Note again the equivalence between the semantic network and the frame representations. The three objects and the three frames corresponding to three objects. The relationship between the objects and the relationships being captured by these blue lines here between the frames. While we can capture relationships between frames through lines like this, where one frame points to another frame, we can also capture them more directly by actually specifying variables or other frame names. So for example, for the frame Y, we might say inside X, which captures the same idea that we were capturing by drawing a line between them. In fact, this is the notation we'll use for the rest of the exercises in this lesson. Let us do an exercise together to make sure that we understand frame representations for images like this. So consider the image shown here on the top left. Can you write down all the slots and the fillers for these three frames? David, were you able to write down the slots and the fillers?
I was. So for object X, I have that it's a large triangle that's not filled in. For object Y, I have it's a large circle that's not filled in. And for object Z, I have that it's a small circle that is filled in. As far as the relationships go, in this case we have that Z is inside Y, Z is inside Y, Z is above X, which it is, and Y is also above X, Y is above X.
Good, David, that sounds right to me.
So we have seen expert system in the form of production system in module 1 and rule-based system in knowledge representation, and we have a topic based on expert system in the next module as well. So this topic is being covered in 3 of your 5 modules. So if you view this on the examination point, this is an important topic. You can expect an essay question on expert system and some short answers ones from the topics that are being covered in between, like forward chaining or forward reasoning, backward chaining or backward reasoning, interface engine, knowledge base, working memory, and so on. So on the examination point of view, this is an important topic. So you have to be very thorough with this topic.